This lesson is for Advanced Algebra, Lesson 5-7, on graphing inequalities in the coordinate plane. Students have been doing graphing of inequalities with me earlier in the chapter, where we graphed them on the number line. This is now graphing on a coordinate plane, so we're going to be graphing lines in multiple directions. There will be three different types of graphs, three different types of lines that you're going to run into. They could be oblique, which is another word for diagonal. And if they are diagonal, they'll be coming from either the slope-intercept equation or the linear combination or standard form equation. Real quickly, when you graph an oblique line that's in slope-intercept form, you start with the b value, which is the y-intercept, and you use the slope from there, rise over run. If you're working with the linear combination equation, you would make a quick little table and you'd fill in 0 for x, 0 for y. You'll have your x and your y-intercepts. You'll be able to graph from those 2 points. If you have y and then any inequality, not just the greater than, but any inequality and then a number, that's going to result in a horizontal line. Anytime you have x and then any inequality and then a number, that's going to result in a vertical line. So students should predict in advance what type of line they're going to have. Before they actually draw the line, they should determine what kind of boundary line it's going to be. The boundary line will either be dotted or dashed if it's got a less than or greater than symbol. If it's got a less than or equal to or greater than or equal to, then the line will be solid. All that means there is whether or not the boundary line is included in the answer or not. Included would be the solid, not included would be the dotted or the dashed. After you've drawn the line as either dotted or solid, then you'll need to shade. And for shading, you're going to have a couple different options. Sometimes you can simply use logic. You can look at the way the equation is worded or the inequality is worded and you can tell which side to shade on. When you're not sure, you're going to use something called a test point. Typically, I use the point 0, 0 as my test point because 0 is really easy to multiply by, but know that you can use any point that's not on the boundary as your test point. Keep in mind that for some word problems you will not shade, you'll use what's called lattice points or dots, and I'll show an example of that at the end of the video. So we're going to do these 4 examples real quickly, and then I'm going to have students pause the video and try 4 more. On this first one, y is greater than or equal to 4. I know that that's going to be a horizontal line at 4 on the y-axis. 1, 2, 3, 4. I know it's going to be a solid line because the greater than or equal to symbol. If the equal to was not there, then I would have drawn a dashed line. Now I'm looking for y values that are greater than 4, and I know indeed that those are going to be above the line. So that's where I'm going to shade everything above the line. And sometimes, just to make sure, I put a little arrow to indicate that it does keep going above. Let's go to the right for x is less than -1. So I'm going to go to -1 on the x-axis and put a dot. I know I'm going to be doing a dotted or a dashed line at that point, and I know it's going to be vertical. X and then a number is always going to be a vertical line. Then, if I'm looking for x's that are smaller than -1, I know that those are indeed to the left. So I'm going to shade up to the line and then everything to the left of that. Down here on the left, I know that this is an equation in slope-intercept form, so I'm going to start at 1 on the y-axis. That's my b value. So 1 on the y-axis. And then for my slope, I'm going to put the negative with the top number. So when the slope is rise over run, I know that the top number of -2 means I'm going to go down. The bottom number is positive, so I'm going to go to the right. So I went down to right 3. And then I know I'm going to do a dashed line because there's no equal sign. So I put a dotted or a dashed line in between those points. And now I need to figure out where to shade. As far as shading goes, if I plug in the point 0, 0, 0, 0 is on this side of the line. So if 0, 0 makes this a true inequality, then I know that the solutions to the inequality are below the line. If 0, 0 makes it false, then I know that I'd be shading above because all the answers are not on the side where 0, 0 is located. So I'm going to plug in 0 for y and 0 for x. Now when I do -2/3 times 0, I know that that makes 0, and 0 plus 1 is 1. So I end up with this statement when I use my test point. 0 is greater than 1. I know that that's false, so I know that the answers are not on the side where 0, 0 is located. So that means I'm going to shade above the line. Some kids say that they know that it was going to be above the line just because the symbol is greater than, and I've found that that's not entirely intuitive. So I would tell kids, that's okay, but I would try to use some math to back up your reasoning. Just because it's pointing to the right doesn't necessarily mean we're going to be always shading to the right. Depends upon the line. On this equation, you can solve for y. That's one option for you to try to figure out how to graph it. You can get it into slope-intercept form if you'd like. I would like to push students towards using a table because that's what we're going to be doing later on in the chapter for various reasons. So I want students to start to get comfortable making the table instead. If I plug in 0 for x, that basically means that that part of the equation is going to go away because 2 times 0 is 0. And then we're just going to pretend that this says equal sign here, and we're just going to solve. So 3 times what is 6? We know that that would have to be a 2. Now if I plug in 0 for y, then that makes that part of the equation go away, because 3 times 0 is 0. 2x equals 6. Now I know that that x needs to be a 3. So now I'm going to graph 0, 2, which is up at 2, and 3, 0, which is out at 3. I'm going to do a solid line to connect those, and then I got to decide where I'm going to shade. To decide where to shade, I'm going to plug in 0 and 0 at the same time. 2 times 0 is 0, 3 times 0 is 0, 0 plus 0 is indeed less than 6. That's a true statement. So I know that 0, 0 is the side where the answers are. So I'm going to shade below the line this time. Again, some students would argue that the inequality is pointing to the left, so that's clearly the side we should shade on. Again, I don't know that that's entirely intuitive, so I would recommend that students use the test point each time. So I'd like students to give this a try now. There's 4 more questions similar to the ones that we just did. Students, quickly copy these and give them a try on your own. Be careful here, a lot of times an optical illusion happens on this one here, making students believe that that symbol goes with the slope. That is indeed a positive slope. Down here that symbol is going with the inequality, indicating greater than or equal to, not negative. So students, pause the video and go ahead and give these each a try. Answers are posted here. Just want to point out on the first one here with the y value, you are going less than 2. Make sure that your shading doesn't stop at the x-axis. Make sure it goes below. The next one here should be a vertical line. Next two are oblique. Here we're shading above, and also here we're shading above. Notice here we made the table in order to solve the linear combination equation. So the homework will have students practice that even further. Lastly, I would like to point out to students that there will be situations where you will do lattice points, meaning you'll shade below the line, but you'll only indicate the answers are going to be where the grid lines cross. So if you look at this example, she wants to buy pens and erasers. When you go to the store, you're not going to be able to purchase partial erasers or partial pencils, so only whole number answers would make sense. You can buy 1 pencil and 1 eraser, or you could buy 2 pencils and 1 eraser, or any of the combinations that are listed here as dots. We would not be able to buy 8 pencils and 1 eraser because that's clearly on the other side of the line. You wouldn't have enough money to do that according to the situation. So only the spots where you have clear dots indicated would be proper solutions to this situation. So when you see typically a word problem where you can't buy portions of things, those are typically the type of problems where you're going to be using a lattice point rather than shading. If you work through a problem and you forget about lattice points but remember it at the end, feel free to shade in and then write a note or go back and fill in the lattice points where the grid lines cross.